Uh, Welcome to the course VLSI Physical Design Automation. In today's session, we are going to talk about another one unique partitioning algorithm which can provide a successful k disjoints of a given circuit or a graph. So that algorithm name is nothing but like FM algorithm, and the FM algorithm will also having some set of terminologies before while you are going to practicing the FM algorithm based problems. Okay. So one thing we should remember before getting into this FM algorithm and its terminologies, in the last session we were handled about KL algorithm and its terminologies, and followed by we tried to do a successful partitioning by means of using the KL algorithm. So where if you are noting down very closely, the KL algorithm is going to be getting function based on a pair of nodes going to be get swapped between one partition to the another partition, right? So the thing is that like in KL algorithm, which we have seen in the last class, we always consider a pair of nodes. We will consider a pair of nodes is getting swapped between the partitions. Okay, and also we can notice that the KL algorithm will be applicable only for the a graph which holding the 2n nodes. Means we can tell that KL algorithm can be applicable only for the graphs which is holding the even number of nodes. Okay, so that is what the last sessions when we talked about in the KL algorithm based partitioning problem solving. Okay, so let's see in today's session how this FM algorithm is going to performing to do a successful partitioning of a given circuit or a graph, and what kind of differentiation we have between your KL algorithm and as well as in the FM algorithm. Okay, so if you're going to take an FM algorithm, the first thing about this FM algorithm is nothing but this FM algorithm is not only applicable for 2n graph, it is also applicable for a 2n plus 1 graph. Okay, what is the meaning? It can able to applicable for your odd number of graphs, means we can able to have the odd number of nodes in a graph, so that is not an issue while you are going to talk about your FM algorithm. That is the one of the main difference which we can see between your KL algorithm and FM algorithm. So since we can able to handle a 2n plus 1 nodes, so what is its operate? It's based on a single cell can be moved independently between one partition to the another partition. Whereas we have seen just now in KL algorithm, we are using a pair of nodes to swap between one partition to the another partition. Okay, but here we are just making use of a single cell to move independently, so there is no need of any pair of nodes to choose between one partition to another partition. Instead we can move with one cell between it can just make a move from a partition which is holding now, and it can move to the new partition area. Okay, and no need to maintain an exact partition balance is also another one important factor which we can talk about over here in terms of FM algorithm with respect to KL algorithm. So what is the meaning of a partition balance over here? So when we talk about the KL algorithm, as it is dealing with the 2n graphs, and means it's dealing with the even number of nodes in a graph. So while you are going to do a final partitioning by using KL algorithm, we can see that the volume of a partition A is equal to the volume of partition B, that is equal to n. It's nothing but number of nodes, means it should be equally partitioned. That is called the balanced. But here, since we are dealing with the odd number of graphs also, means we are dealing with the graph which holding the odd number of nodes, so we can't able to expect that your volume of partition A or the volume of partition A, volume of partition A will not be equal to volume of partition B will not be equal to n. So what is the meaning? The number of nodes which is present in your partition A may not be equal to the number of nodes which is present on your partition B. So that is what we can talk about your partition balance. Okay, let's say for example, if I have a graph with the 5 nodes, if I have a graph with the 5 nodes where this n is indicating the number of nodes. So how the way that final balanced partition, in the sense the balanced partition is not at all possible here. There is no possibility of balanced partition here, because we have odd number of nodes over here. Then how come that your unbalanced partition can be, you can say that in one partition there can be 3 nodes, in another partition there can be 2 nodes, or it can be a vice versa. In one partition it can be 2 nodes, in the other partition we can able to have 3 nodes. So that is what we are talking about, that that is not required to maintain the exact balance. It is not at all possible when you are going to handle this 2n plus 1 nodes graphs over here. Okay. That another thing is nothing but the area of the cell is going to play a major role when we are going to consider this FM algorithm. Means the every nodes which is occupied on the graph will have its own respective cell, its own respective area, and that area is going to take into account to do a successful partitioning by using FM algorithm. And second point is nothing but like it is applicable for unequal size in the presence of your initially fixed cells. It's another one thing we can able to see it as a future when we talk about this FM algorithm over here. Okay. So followed by the FM algorithm cut cost. Okay, what is the cut cost? The cut cost is going to be the major role in the partitioning, right? There are two goals we have, we have in terms of the partitioning. One is nothing but your successful k disjoints. Okay, and second one is nothing but partitioning, balanced partitioning. Okay. So to do this, and we have an objective function. What is the objective function? We can say the objective function is nothing but cut size, or we can say it's going to be a cut degree. Okay, to achieve this goal we have an objective function that is nothing but a cut size or and cut degree with respect to your partitioning. So according to the FM algorithm, of course we can able to make a k disjoints, and also just now we have seen that in terms of the balanced partition, that is not necessarily to have your equal balanced partition is going to be get happen, but at the same time we can see that the cut size has to be get reduced, or the cut degree has to be get reduced. That is what the important thing when we talk about this either KL algorithm or the FM algorithm over here. But what we can say over here, the cut cost are extended including the hypergraph. That is another one important point, we should note it down, and it is get differentiated from your KL algorithm to the FM algorithm. So FM algorithm says that it is more useful for to handling with the hypergraph. Okay. Fortunately, all the VLSI circuits so far which we have in practicality, it's just following an hypergraph connectivity, so that this FM algorithm will be more useful when we talk about your VLSI circuit partitioning when compared with the KL algorithm. Okay. And what it says that the nets with 2 plus pins can be get supported when we talk about this partitioning of your FM algorithm, right? So what is the meaning of it? Let's say for example, let us assume a circuit like this. There is one AND gate, and this AND gate is driving one NOT gate, and let's say it's going to be driving one more an XOR gate, and it is driving one more buffer. Let me consider. So this is going to be first cell, second cell, third cell, and fourth cell. So how come we can able to plot an equivalent graph for this when we considering this FM algorithm? We can plot likewise the node 1, here I have node 2, here I have node 3, here I have node 4. From node 1 we can have one net, and one net can be get connected to 2, the same net can be connected to 3, and the same net can be connected to 4. Okay. So normally we used to call that is going to be edge here, this is edge, but it is not a normal edge, it is called a hyper edge, because from one node there are 3 nets going to be getting connected. That's what it says that when any circuit which is having the nets with 2 plus pins, more than 2 pins. So here we have 1, 2, 3 nets is going to be getting available over here. So nets with 2 plus pins is going to get satisfied, and we are converting that into a graph, and we can see that this edge we can able to call it as your hyper edges. Means from one edge we will have the multiple connectivity between your one node to the another node. So this edge we can call it as a hyper edge, right? So while KL algorithm aims to minimize cut cost based on the edges, but when we talk about FM algorithm, it's try to minimize the cut size based on your nets, what is it available. So nets here is indicating your hyper edges which is present on your graph. So what we can conclude when we talk about this FM algorithm, the FM algorithm is most suitable and applicable for hypergraphs rather the normal simple graph, right? Done. Let me just get into the terminologies. What are the different terminologies are available on FM algorithm? So in the first terminology of your FM algorithm is nothing but a gain del G of every cell. Gain del G of every cell means irrespective of the position of nodes which is available on the hypergraph, either the node can be in partition A or partition B, we have to calculate as initial gain value, it's indicated as del G by the formula called del G of C is equal to a moving force minus retention force. Okay. So the moving force is written in terms of your Fs of C, and minus the retention force can be written in terms of your T of C. So this is the conventional method by which we can able to represent the gain of a cell on FM algorithm. So for our easiness, if you want to assume, we can assume like this: moving force of C minus retention force of C. So this is for our local remembering, we can able to even reconstruct the function like this for del G of C is nothing but. Now what is meaning of moving force? What moving force says that the moving force is the number of nets that connected to C but not connected to any other cells within the C's partition. Okay. And also it indicates that is what is the meaning, the cut nets that connect only the C. So we have to consider the nets which is cut by the cut line, and it has to be connected between your C and the one partition with the another partition, but not within the partition. That is what I try to say about your moving force. And what retention force says that the retention force is nothing but the number of uncut nets that is connected to C. So that is what the formula we can derive for your gain of each and every cell on your FM algorithm. Okay. So what this moving force is indicating over here, the moving force is indicating here is nothing but what is the benefit we can get if we are going to move that specific cell from one partition to the another partition. So we should carefully note it down over here. We are using in FM algorithm only a single cell is getting moving at a time between one partition to the another partition. So there is no any pair of swapping is not going to be happen over here. So that while I am going to talk about this moving force, so if I am going to move that particular cell from one partition to another partition, what is the benefit? So that is what can be indicated by means of this particular moving force. What the retention forces talks about, if I am going to retain that cell within that partition and I am not moving that particular cell or the node from one partition to another partition, what is the benefit of it? So that is what we are trying to gain from this moving force and as well as in the retention force. Okay. So that let me try to understand this moving force and retention force from taking one simple graph. Okay. Now what is the benefit of this del G? Before getting into the graph, what is the benefit of this del G? So here also we can say that when del G value is greater than 0, okay, when del G value is going to be greater than 0, what does it indicate in the sense it is having a more priority, the cell holding a more priority or the node having a more priority to move from one partition to the another partition. That is what it is representing it. Okay, and whenever as per your KL algorithm, as like KL algorithm also here, whenever the del G value is less than 0, that cell will retain more possibility to retain on the same partition and it may not move from one partition to the another partition. That is what the significant indication we can gather from your estimation of your gain of every cell of a graph. See this particular graph. This graph is the best example for your hypergraph. So why we are calling this as a hypergraph? We can see that there is a connectivity between your 1, 2 by means of the here we have that your edge is A, and if you can note down your edge B, what edge B is indicating that the edge B is not only connecting between your 2 and 1, the edge B is also connecting between your 3. So what is it meaning of it? It's meaning that the 3 is get connected to 2 as well as the 3 is connected to 1. That is what the meaning. And this edge is called it as your hyper edge. Okay. If it is not a hyper edge, how come that the simple graph can be get drawn? The simple graph can be drawn by means of drawing like this. 2 can be here, 3 can be here. So and 1 is available in this way, and the 1 and 2 is already have get connected. So instead of having your 2 to 1 and then to take 3, we can directly connect your 3 here, and also we can able to directly connect from 3 to 1 like this. So this is your simple graph representation. But we have seen that the FM algorithm is not applicable for the simple graph, we are applicable for the hypergraph, so that we consider your hypergraph over here, and this edge B we call it as your hyper edge. We are writing that edge B is hypergraph, hyper edge. Okay, that is the meaning. So it is connecting between 2 to 3 as well as your 2 to 1. That is the meaning of it. Okay. So now let me try to estimate your let's say we try to estimate your del G of C for one cell. So how come that estimation of cell 2 can be done? The cell 2 can be done by means of what is the formula? Del G of 2 is equal to Fs of 2 minus, we can say it is nothing but T of 2. Okay, what is Fs of 2 is saying that it is a moving force of 2 minus T of 2 is what is it says that it is nothing but retention force of 2. Okay, so for 2 we have to calculate this moving force as well as the retention force. So let's say try to understand what is the moving force estimation. What moving force estimation says that from your previous slide, the moving force says that we have to consider the edge. We have to consider the edge which has to be cut by the cut line, and it should be get connected between one partition to the another partition. At the same time, the edge should not have any connections between on the same partition. Okay, so let me assume that we are going to have your 2 alone. Let I just maximize your 2 alone over here. Let me take 2 alone here. So from 2 it is going to 1. Okay, from 2 it is going to 1. So it is coming to 1. What is the net name? It is A. And from 2 it is again what is the diagram? It shows that it is just going to 3 also here. Here it is going to 3 also here. And it is cut by the cut line, right? And it is cut by the cut line. Now it is cut by the cut line like this. Just we are magnifying only these 2 and its respective connectivity to understand how to calculate your moving force. Now see that according to the definition, we should consider the edges which is cut by the cut line. Means here this is the edge which is cut by the cut line. We can see that this edge is cut by the cut line like this actually. But what is another criteria? It says that to calculate the moving force, we should consider the edge cut by the cut line. At the same time, the edge should not have the connection between on the same partition. Means this edge should not have a connections on the same partition. Means we consider your cell 2, from cell 2 to cell 1 there is a connectivity. Means this edge is connecting on the same partition. So we should not consider your edge A for the processing. And let me come to the edge B, because here edge B, right? So what about your edge B? The edge B also having that connectivity between 2 to 1. Within the cell partition there is a connectivity is available. So this B is not going to get considered with respect to this partition. But what about this edge B? The edge B is connecting between from 2 to 3 also. But the thing is that this is not a normal edge, this is called a hyper edge. Means what is the meaning of it? The cut line which is cut by this here is going to be equal to the cut line when it is going to be cutting here also. Means what is the meaning? This is the edge which is present on the same partition, it is extended to the other partition. So according to the definition, we should not consider this B also for the account of estimation. So what we can write over here, so that the moving force of 2, the cell your node 2 is become 0, okay, minus, then what about your retention force talks about? The retention force talks about the number of edges which is cut by the cut line, okay, and it is not going to be worry about that whether it is connected within the partition or it is connected from between one partition to the another partition. So accordingly what we can see that we can witness that this edge is, this cut line is cut by this particular edge B, so that what is the meaning of it, it's cut by this line, it indicates that it's equivalent to that it's cutting over here also. So how many edges it's cut by the cut line? It's cut by only one edge is going to cut by the cut line, so we can write as 1. So 0 minus 1, the value of minus 1, we can say del G of 2 is equal to minus 1. Okay, so this is what the way we can able to estimate your gain of cell which is present on a graph, okay, or the gain of a node which is present on your hypergraph over here, okay, right. So let's see that the same graph we take into account, and over here we try to estimate what is the del G value of every cell, okay. What is the del G value of every cell? Let me try to estimate over here. Let's say for example del G of 1, let me try to calculate. The del G of 1 talks about your Fs of 1 minus T of 1, we can say. So what is your Fs of 1 value for your 1 over here? So Fs of 1 is nothing but there are two edges getting cut by the cut line according to this particular diagram, a hypergraph. If from a node 1 we can say that there are two edges which is cut by the cut line. At the same time these edges doesn't have a connectivity between one node to the another partition, one node to the another node within the same partition, so that we can take into account your C and D can be taken into account. At the same time the A will not be get considered, the edge A will not be get considered, and the edge B will not be get considered. Why? Because the edge A is having the connectivity between your cell 1 to cell 2 within the same partition, so we should not consider. And while you are talking about edge B also connecting between your one cell to the another cell within the same partition, so that we should not consider, even though this hyper edge is cut by the cut line, because it is a hyper edge, so it's not going to be getting taken into account. And the C and D get considered. Why? Because the C and D edges it's not connecting within the partition, instead the C and D is connected with the other partition, so that we can consider your C and D. So we can write Fs of 1 value is nothing but 2 minus, what about your T of 1? T of 1 is nothing but the number of edges which is not cut by the cut line. So how many edges which is not cut by the cut line with respect to 1 we are writing. So with respect to 1, what are the edges are available now? A, B, C, D is available. Now we are not going to consider your D now for estimating your retention force. To estimate the retention force, D will not be get considered because it's cut by the cut line, and C is also will not be considered because it's cut by the cut line, and followed by the B is also will not be get considered, since it is a hyper edge, it is cut by the cut line, so that we are not going to consider the B also. But for the retention force we should consider only the uncut edges. So means only A can be get possible with respect to for your retention force, so that we can write 1 value 2 minus 1. So what is the final value is nothing but del G of 1 value is nothing but 1. So now I hope you are understanding about how to calculate your del G value of every cell which is present on a graph. So likewise we try to estimate the gain value for all your cells which is present on your hypergraph, okay. And after seeing that, according to the formula, what is the formula we have? Del G of C value must be greater than 0 to check the eligibility. Means whenever the del G C value is greater than 0, what is the eligibility is nothing but that particular cell can be make a move from one partition to the another partition. And when del G is less than 0, that particular cell can be retained on the same partition, and it is not eligible to move from one partition to the another partition. Accordingly, here we can able to witness that your cell 1 having the eligibility to make a move from one partition to another partition, and also we can say that your cell 5 is also having an eligibility to make a move from one partition to the another partition. Correct? Your cell 1 and cell 5 having eligibility because both are 1, and after that there is -1 and 0 0 is available. So this we are not going to consider to check the eligibility. So here there is a competitor, right? Cell 1 is also an eligibility to criteria to make a move, and cell 5 also is going to be eligible to make a move from one partition to the another partition. So we can't take a decision whether the cell 1 is movable or cell 5 is movable, since both are having the same value. So we have to consider there are some remaining factors also available on FM algorithm to take a decisions that whether cell 1 is eligible or cell 5 is eligible to make a move. Okay, right. So now let's here for an assumption we assuming that your cell 1 is moving. Okay, as I discussed early, there are two eligibilities available, cell 1 and cell 5. Okay, but we are going to consider other factors also that to be take a decision whether cell 1 is moving or cell 5 is moving. But for here for the discussion, let me assume that your cell 1 is moving. Means what is the meaning? Your cell 1 is moving from the partition where it is existing to the other partition. Let's say for example this is a partition A and this is a partition B we consider. Now the cell 1 is available in a partition A, and here after the estimating with del G value, the cell 1 is have eligibility to make a move. So let me assume that the cell 1 is make a move from this partition to the another partition. So before movement, so I do remember before this cell 1 is getting moving, what is your A partition? The A partition consists of your cell 1 and cell 2. And what is your B partition is consist of? The P partition is consist of 3, 4, 5. These are the cells we have. Let's say now the cell 1 is getting moving because it is have eligibility. So cell 1 is getting moving from one partition to the another partition. So means what is the meaning? It is moving to the other side like this, right? So one is moved on the other side. Now what is your new partition A now? The A will consist only of 2. And what about B is now? B is nothing but 1, 3, 4, 5. So this is your new partition cells which is holding available once the 2 is getting moved from one partition to the another partition. Because according to the FM algorithm, there is no paras cell is get swapped over here. There is only one cell is going to be getting chosen at a time to make a move from one partition to the another partition. Okay, right. And according as per the KL algorithm and in FM algorithm also, we are going to estimate your GM, and GM we are estimating with respect to the number of moves of cells over here, and we try to estimate your the final gain margin value, how much we are going to gather with respect to the every pass, and this the maximum G value is indicating that the maximum cut size can be reduced as like similarly like a KL algorithm. Here also we are estimating it over here, right? And the maximum positive gain GM is the cumulative cell gain of M moves that produce minimum cut cost. Okay, that's what we discussed now. And GM is determined by the maximum sum of cells of your every del G make a movement. So whatever the del G value you are choosing to make a move of the cell, the del G value can be get added over here at every end of your iterations, right? Done. So followed by we have one more new terminology over here, the ratio factor. Okay, so what is this ratio factor talks about? This ratio factor is given that much important over here to in order to maintain the relative balance between one partition to the another partition. Means please note it down, we are just to maintain the relative balance between one partition to the another partition. Means we are not going to make an equal balance between one partition to the another partition. We just try to make how relatively we can able to make an equal balance between one partition to another partition in a least manner. There won't be any major drastic imbalanced partition. We try to bother about the relative balancing by the way, by means of the least reductions of the balance we can able to take a successive k disjoints when you talk about this FM algorithm. So that can be done by means of using this particular ratio factors. That is point number 1. And second point to consider your ratio factor is nothing but to make sure that all the cells will not be getting to align on a one partition area. Okay, that's what you can note it down on your second point. It is used to prevent all cells from clustering into one partition. That can be get avoided by means of using this ratio factor. Okay. So to do so, we have a formula for ratio factor. How we can estimate the formula for ratio factor? The ratio factor is telling you it is a fractions of the value between area of A and area of A plus area of B. So here that A and B are indicating that your A and B are indicating the partitions. Okay. So A and B is indicating the partitions. Let's say for example, what is the graph we consider so far? The graph we considering is nothing but 1, okay, here 2, here 1, the example graph which we are considering, right? And here we have a 3 and 4 and 5. These having a hyperedge, and from here we have a connectivity, and here we have a connectivity, and here we have a connectivity. This is what the cell hypergraph we are considering for the discussion, right? So I can say that this is my partition A and this is my partition B. Okay. Now what is the area it talks about now? Before getting into area, let me just discuss what is your total area of your partition A. So we can say that the area of partition A is nothing but area of cell 1 plus area of cell 2, right? Are you understanding? Means what is A is consist? A partition consisting of your cell 1 and cell 2. So area of A is equal to area of cell 1 plus area of cell 2. That is what area of A is indicated. Then what about your area of A plus area of B is indicates that is nothing but total. This is implicating that total area of B, means B is nothing but what? All the vertices which is present on your hypergraph. Okay. So that is called your area of B. So we can say that the ratio factor formula is can also written as R is equal to area of A divided by area of all vertices which is present on your graph. This is what the ratio factor talks about. Okay. So here we are representing that where A and B are the total respective areas of your partition A and B, right? Done. So next, another one important terminology about your FM algorithm is nothing but a balance criteria. What the balance criteria speaks about? So the balance criterion is enforces the ratio factor, because the balance criteria will be works based on the ratio factor. And what purpose we are making use of this ratio balance criteria? To ensure the feasibility and the maximum cell area must be taken into account in order to balancing from between one partition to the another partition. As we discussed in ratio factor, we just try to see that at least of the least level we can consider to see that how we can make a maximum balancing and maximum to avoid your unbalancing by considering this both ratio factor and the balance criteria. So how we can able to estimate this balance criteria based on this particular formula. So a partitioning of V vertices into two partition A and B, it can be referred by means of your R dot area of V minus area max of V, and should be less than or equal to area of A and less than or equal to area of V plus area max of V. So means we are trying to define the area of A means area of one partition by means of an upper bound, lower bound value. We have lower bound value, lower bound less than or equal to area of A and less than or equal to upper bound V. Okay. So this is indicating your lower bound value of your partition A, and this is indicating your upper bound values of your partition A. So we are try to create a formula through which we try to analyze that what will be the minimum lower bound number of cells can be occupied on partition A, or what will be the maximum cells of your upper bound, what is the maximum cells of your can be get occupied on your partition A. So we are defining that lower amount of cells which can occupy on partition A and the maximum number of cells which can occupy on partition A. So that we can defining by means of this particular balance criteria, so that we can able to make sure that to maintain maximum balancing between one partition to the another partition. So here the area of V is in nothing but the total area of the cells which is available on my a particular graph. So cell is indicating what the vertices available on your hypergraph, and the area max is nothing but what is the maximum cell area among your all vertices, that we can able to consider as the area max of V. Okay. Then followed by the balance criteria, we have one more terminology on the FM algorithm, that is nothing but base cell. So what the base cell is indicating, the moving cell is decided by the del G value, am I correct? When del G value is greater than 0, that cell having the eligibility to make a move. So okay, so that cell is making eligibility to make a move. So whatever the cell is going to be making move based on the satisfying the criteria of your balance criteria and ratio factor, that cell we call it as what? A base cell. A base cell is a cell C that has greatest cell gain del G among all free cells and whose move does not violate the balance criteria. What is the meaning of violating the balance criteria? It should be fall between a lower bound to the upper bound. Okay, the value of your moving cell, the area of your moving cell should be fall between the lower bound value or to the upper bound value. Only that particular cell we can call it as what? A base cell. And once this base cell is getting moving, once the base cell is moving from one partition to another partition, then we can call that base cell as a fixed cell after the movement. Okay, on the post movement of your base cell from one partition to another partition, we can consider this base cell as what? A fixed cell. Okay, right. So here, as per the discussions of the previous, we have considered that your cell 1 is getting moving, and we are assuming that this cell 1 is satisfying the balance criteria that we will estimate later. And for the discussions over here, let me assuming that your cell 1 is satisfying the balance criteria and cell 1 is getting moving, then we can call this particular cell as what? Base cell. So means what does it mean? Your cell 1 is getting moved out. Accordingly, how we can draw the diagram? We can draw the diagram like this: 1, this is 2 because this is 1, and this we can call it as what? 1, this is 3, and this is 4, and this is 5. And here we just plot your edges on different color like this according to your example discussions graph. This is what the graph we have considered so far, and it is cut by the cut line, correct? It is cut by the cut line. Now what is it, how we can draw the cut line now? Your cell 1 is moved. Cell 1 is moved from, previously it was in this partition, it is on your A partition. This is our A partition and this is our B partition. Previously the cell 1 was with your A partition, now it is moved out to a B partition. So how a cut line can be drawn? The cut line can be drawn like this for the new one. Okay, previously it was straight line, now it is moved on to this particular one actually. Okay, so now once it is this one is get moved, what we can say that your cell 1 is nothing but now base cell. Okay, it is moved from one partition to another partition. Once the movement is over, we can call this base cell as what? Fixed cell. Means now we can say that on partition A we have only cell 2, on partition B we have what? 1, 3, 4, 5, and in this particular one we can say that now the fixed cell is nothing but what? Your 1. And what about your unfixed cell? Your unfixed cells are nothing but 2, 3, 4, 5. Means at any time the cell 2, 3, 4, 5 can be make a movement from one partition to the another partition. Okay, that is the meaning over here. So followed by, let me try to understand what the steps and procedure we should follow. If a problem is given for us to solve the problem by using that FM algorithm, the first step is to compute your balance criteria by using the ratio factor, and followed by in step 1 we can able to do a compute of your gain of each and every cell, and in step 2 we can do that your choose the base cell based on the maximum gain del G, and also we have to see that whether the del G is satisfying the balancing criteria, because Once you have chosen that cell as a base cell, then we have to see that the base cell is satisfying the balance criteria, means it should satisfy that it should fall between the lower bound to the upper bound value with respect to balance formula. And fix that base cell. Once it is movement is done, once it is fall between your lower bound value to the upper bound value, we will call that base cell as a cell as a base cell, and we can fix that base cell as a fixed cell and update all the cell gains connected to critical via the base cell Ci. And coming to step 4, if all cells are fixed, then we can go to step 5. If all are fixed over here, then we can come over here. If it is not fixed, then we have to go for estimation of the del G value again, and we have to go for to satisfy the balance criteria, and once it is got balance criteria gets satisfied, we can move the cell, and accordingly we can able to update our fixed cell. In case it is going to be getting that satisfied, then we can determine the best move sequence over here based on your GM value and seeing that the maximum GM value is going to be getting gathered, and then so that we can able to end your program. Okay. In case if it is not getting over, then we can reset all your M moves, and again we can start from your step 1 and we can continue the procedure until it is going to be getting updated. Okay. In step 4, once again we can this step 4 to step 6 will be get repeated until all your cells get fixed, and also to see that the cells are obtaining the maximum gain GM, so that we are reducing the cut size in a positively, and also we are seeing that your maximum balancing is going to be get maintained between one partition to the another partition. So these are the steps and procedures on your FM algorithm and the important terminology which is involving on the FM algorithm. So based on this terminologies of FM algorithm and the steps and procedure, we try to sort out one of the successful partitioning problem in the next session. Okay, thank you.